Okay, so what we are looking at today, permutations and combinations. Permutations and combinations. They're similar, but slightly different because of one thing. We'll talk a little bit about that when we get to those problems. Okay? So the first thing that we're looking at here is this series of, what looks like just numbers and exclamation points, called factorials. Okay? So what you're looking at here is this 5 factorial, we would call it. How that's represented, how the 5 factorial is represented is 5 times 4 times 3 times 2 times 1. Factorial, when you see that exclamation point, you have that number and everything below it being multiplied together. Okay? So when we have 5 factorial times 7 factorial being divided by 3 factorial times 9 factorial, here's what's happening. Okay? You've got, we'll keep that one blue. What you're looking at here, you can separate it as 2 fractions, kind of. 5 times 4 times 3 times 2 times 1 over 3 factorial would just be 3 times 2 times 1. This looks like a lot of work, but when you're simplifying them, you're going to be able to cancel a lot of these values out, okay? Because when we go ahead and list them out that way, where we have 5 factorial written out on top, 3 factorial on the bottom, what can we cancel out for those common factors in top and 3, 2, and 1 in both the top and the bottom, right? You can be canceling out the fact that both of them have a 3, both of them have a 2, both of them have a 1. Really, this factorial of 5 factorial over 3 factorial simplifies down to 5 times 4 all over 1. That's what all that work did when we're simplifying. Okay? So you're down to just what's going to ultimately be 20 there. All right? So now the other side of it, that's 7 factorial times 9 factorial. We can split these two up like we did here. 5 factorial over 3 factorial times 7 factorial over 9 factorial, just for the sake of making it a little easier to cancel these things. Okay? So then we multiply by 7 factorial, which is 7 all the way down being multiplied by each other, being divided by 9 factorial, which is from 9 all the way down. Okay? So then when I go ahead here and start canceling things out, what am I going to end up with? Where? Good. You're just going to have 9 times 8 left on the bottom. All that 7 factorial is going to be canceled from the top and the bottom. They have that in common. So then you are multiplying these two back together once they're simplified. Right now we're left with 1 over 9 times 8. So to finish, you're just taking care of the end point, very end of this. So 5 times 4 is going to be what? 20. 9 times 8 is what? 72. So you end up with 20 over 72, which simplifies to what? 10 over 36, 5 over 18. That's what I'm trying to do. Okay, you got it. That'd be your final answer. So that whole big mess with decimal numbers and everything simplifies all the way down to that fraction. So the reason why we're talking factorials at any point today is because we are going to be dealing with them within these equations today. So this is your permutation and combination. These are the two things you need to know. Write these two formulas down. They will also be on your notes when we put them on the checklist. First of all is going to be permutations. We're going to talk about that first. Okay? So permutations. Okay? This is where order matters. Okay? So basically, what permutation, well, I'll come back to that in a second. Let's just put the formula down for this here. So you're going to see this as N and then a P and then an R. You're going to see two little numbers there like you do here. 8P4. Okay? So what that formula is N factorial over N minus R in parentheses factorial. No. Okay? Why is everything like this?
It's not n factorial minus r factorial. It is n minus r factorial. Yes. Yeah, that doesn't make sense.
This doesn't make sense. Doesn't make sense at all. Yeah, that doesn't make sense. It'd be 8 minus.
It is how you have it written.
Really? Yeah, oh yeah, on there. Yeah, we got it. Okay. All right. So make sure we're writing this down. So when you do your first example here, okay, we've got 8P4. So what you're going to be doing is just plugging into this situation. Your N is going to be the bigger number, okay? So that's going to be 8 factorial over, and then N minus R factorial, the 8 minus 4 factorial.
That's surprising.
Yes. Yes.
Don't worry about it.
8 factorial over, what's 8 minus 4 going to be? Let's go 4 factorial. Okay. So when we write that out, okay, if we are to write that out, I've got 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1. And what can I cancel? From 4 on down, right? So you are going to end up with whatever 8 times 7 times 6 times 5 is. 1,680. Very good. That is your permutations possibilities. So we're going to compare permutations. We'll explain when we get to a word problem. You're not solving for P. You're finding the number of possible outcomes. Okay, so we'll explain here in a minute. So for C then, that's going to be combinations. Okay, so over here, you're going to have combinations. 5, choose 4. Order does not matter. Okay, so what's happening here? You've got N CR is equal to, this is very similar, N factorial over N minus R factorial times R factorial. Time.
That's right. I looked it up.
Okay. So from here, okay, when you've got 5, choose 4, 5C4, you're going to have 5 factorial over 5 minus 4 factorial times 4 factorial. Well, what is 5 minus 4 going to give us in those parentheses? 1. Okay, so right now you've got 5 factorial over 1 factorial times 4 factorial. Now here's where we're going to lay these things out. So you've got 5 times 4 times 3 times 2 times 1. On the bottom, you've got a 1, and then you're multiplying it by 1 times 2 times 3 times 4. So what are we going to end up canceling out? Or should I put that backwards? I don't want to confuse you.
Oh, that's
1 times 4 times 3 times 2 times 5 over 1. We're going to have from 4 down cancel, so you're just going to have 5 over 1, right? This is pretty much it. Yep. So here's what I want to just kind of show you the situation with it. All right. So that's your first example of how these two things work. Order matters or order does not matter. Here's what we mean by that. Okay. Suppose we want to choose 2 objects without replacement. Okay. So basically what that means is if I pick a name out of a hat, I'm not putting it back in the hat for the next name I pick, right? So we're running out of those options as you pick them. There becomes less options as you choose them out. From the 3 objects of pencil, eraser, and dent. So basically what we're looking at here is we have 3 options, and we are looking to pick 2. Okay? Now, how many ways can this be done if the order of the choices is relevant? This is where you would do permutations. Okay? So what you're going to have there, your N is the number of options. Your R is how many you're choosing. So you've got 3 options. You're picking 2. So the way that that's going to be set up is going to be 3 factorial. So let me just do this down here a little bit. So 3, pick 2, you're going to have 3 factorial over 3 minus 2 factorial. Minus 2 factorial is what? 1 factorial. So we've got 3 factorial over 1 factorial, which is 3 times 2 times 1 over 1. 3 times 2 times 1 is 6. 6 over 1. You are going to have 6 different ways of doing that. Okay. Now I'm going to do these 2 pretty quick here, and then I just want to talk real briefly about what this looks like visually. Okay. So then, if the choice is the order is not relevant, that's combinations. Okay, that's combinations. So what's going to happen there is 3C2, where you'll hear 3 choose 2. So we've got 3 choose 2. You're going to be looking at 3 factorial over 3 minus 2 factorial times 2 factorial. So that's going to simplify out to 3 factorial over, again, 3 minus 2 is 1 factorial, and then times 2 factorial. That's going to come out to be 3 times 2 times 1 all over 1 times 2 times 1. Essentially, what can we cancel out there? 2 and 1, or canceling the 1 really doesn't matter. You're going to end up with what? You're going to end up with 3. Okay, now I just want to add real quick here. The video is almost done, so for those of you that are watching this here, 7th hour, I'm going to wrap the video up here. If you check your notes on the checklist, I will have that last example done. Okay, and then we'll end on that word problem, and everything should look pretty similar to slides 3 and 4. So those of you on the video, go ahead, get to work, and we can address any questions that we have next time I see you, which should be tomorrow.